Hi everybody, this is Todd Frazee again. This is the training tutorial for Fusion 360 CAM to do the CAM on part 12B for the TCOSE assembly. If you look at the drawing on the TCOSE assembly, part number 12 is made up of two parts that are brazed together. There's another video for the part A. What I called part B was the circular part, and that's what this tutorial will go through. So first we're going to open our data panel and we're going to open your 12B model. Should look like this. And let's close the data panel so that we have more space. Now the next step is to switch into the manufacturer workspace. Now that we're in the manufacturer workspace, we need to create a setup. So you highlight setups and click this icon here. It says setup. And it's going to throw a yellow box around it that represents the stock. The very first thing we need to do is set what that stock boundary is. So on the sides we're going to go 1/2 inch because we're going to have to hold on to something. And on the top we're going to put 0. This part is 3 millimeters thick. We're going to assume we can buy material that thickness for this part. So our rough stock at the moment works out to almost 2 inches square. So we go back to the setup page, and on a circular part it's kind of academic which directions X and Y. So we're going to leave the current orientation alone, but we are going to change the box point to be at the back left corner. Be consistent in our setup. Then we're going to go to post process and we're going to call this 1202. Now we're going to make this part in one setup. The 12 is for the -12 part. The 02 is for the second program because the first program is going to cut the A part. We're going to put on this 12B operation 1. And that'll pop up in the notes, so it'll clarify that's for the 12B. And we're going to put 1 in our work coordinate system. Select OK, and we're done making the stock for our part. The next thing we're going to do is to machine the hole in the center. Now we're going to get away with cutting this whole part with a 1/16 end mill. We could drill this, but then we're going to run out of room in our tool magazine. So we're not making high production here, so we're going to go to 2D contour and we're going to select, we're going to go to the TCOSE library, we're going to select tool number 5 for 16th inch flat end mill. Select OK. We're going to bump these feeds and speeds up. We're going to go 6,000 RPM. And then our cutting feed rate of 7.2 is fine, but 39 inches a minute is way too fast. So the defaults on this are way off. And then we're going to go down here and we're going to put in 4, about half, for our plunge and ramp rate. Okay, moving on to the next tab, our geometry is going to be the hole. I'm going to rotate this, make sure that the arrow, and zoom in, make sure the arrow is on the inside of the hole, not the outside of the hole. And then on our heights tab, we'll leave everything here at default. We'll go to passes. We're going to turn on wear compensation. We're going to skip all of this stuff, and we're going to go down to roughing passes and select that box. Now once we've selected that, the box we do want to set is here. It's the step over for the finish pass. 0.005, we're going to put that in there, which is 5 thousandths. And we're going to put in a maximum roughing pass side step of 0.02. And we're going to leave the smoothing deviation alone and leave the number of step overs alone. We're going to do multiple depths. And I'm going to hide passes here so that we can see what's going on in this tab. Our roughing step downs We're going to set that at 0.02, and we're going to do one finishing step down, and that amount that we're going to step down for the finishing is going to be 0.005. We're going to finish at final depth. We're going to rough that final depth. We're going to use even step downs, and the rest of these are irrelevant because there's only one feature we selected. We do want to select smoothing because we want a nice round hole. Let's go to passes. We're going to leave all these at default except for the vertical lead-in radius. We're going to remove it. Set that at 0 and hit OK. So we should have several rough cuts and then a finish cut at the bottom, with the green being the radial lead-ins. Now we're going to go and we're going to pocket these two pockets with that same cutter. Different command, same cutter. So we're going to go to 2D and we're going to take a 2D pocket. Now something that's really confusing in Fusion is they've made the icon for pocket and for 2D adaptive look almost identical. If you really zoom in on it, there's a slight difference in the toolpath, but that probably wasn't a good choice for them to do that. Let's select pocket. 6,000 RPM should stick. The feed rate should stick if we're going to use the same tool. Our geometry, we're going to select the bottom of this hole and the bottom of that slot. Now we need to make sure our arrows are on the correct side. We want it cutting inside the pocket. Just looks good. And then we're going to move on to our heights. We can leave all these at default. The bottom of our cut is going to be the selected contour. The top of our cut is going to be stock top, which is the top of the part. And these planes will represent rapid motion between the orange and the green, and feed rates between the blue and the green when it's going down. Okay, we're going to go to the next tab. We're going to climb cut. We do want to do finish passes. We want to do one finishing pass. Our step over will be 0.005. Feed rates are good. We're going to leave all these at default. I'm going to select this box that says, and our maximum step over, that's a little high, so we're going to go, our cutter is only 60 thousandths in diameter. We're going to go 0.02 with our maximum step over. And we're going to use this morph spiral command. The smoothing deviation, this is for the roughing, that can stay the same. We're going to do multiple depths. Our maximum roughing depth is going to be 0.02. We're going to do one finishing step down, and that's going to be at 5 thousandths. Okay, let's hide some of the passes. Now we're going to go to stock to leave. We want to deselect that. We want to cut right to our finished height. We want to finish only at final depth, and we want to use even step downs. These are irrelevant because they're both at the same height, but if we had pockets at different heights, you could tell it to do order by depth. We're going to go stock to leave is going to be deselected. We're going to select smoothing, and we want 4/10 tolerance there. We're moving on to the linking tab. Everything in the linking tab is going to stay where it's at. And we'll leave everything else at default except for we're going to take the vertical lead-in out. Down here on our ramp type, we're going to go to just a straight plunge. And let's leave the ramp clearance at 0.1. And we're good there. And we'll select OK. Alright, so we have a whole bunch of cuts and then a final finish cutter on the outside. Now we're getting an error. So this yellow triangle is. And it's saying cannot plunge outside of the stock. I programmed this in a prior version and it worked fine. That error it's giving is saying that it can't plunge outside of the stock. There is a way to force it to plunge into a pocket out by the stock, but in this application we don't even want to do that. So I think that's a bug, and hopefully it'll go away in the next version. But if you read this, and it says cannot plunge outside of stock, and we're cutting a pocket. So we've done nothing to tell it to plunge outside of the stock. Now we're going to do our last operation, which is the outside parameter. To do that, we can simply duplicate our contour from the inside. And we do need to move it sequence-wise, so it's after the pocket. So we want to go contour on the center, and then we want to do our pockets, and then we want to go around the outside, which is going to partially break it loose. So let's go to edit that contour, or leave everything on that first tab at default. The second tab, we're going to deselect the geometry, and we're going to select the outside of the part this time, making sure our arrow is on the outside. I'm going to go to the heights tab, and we are going to change the last box. We want to leave a little bit of flash to hold on to the part, and that'll keep the part from releasing from the material on the outside. It's a good way to cheat on a small part. Okay, we're going to go to passes. Everything on here we should be able to leave as default as we had on the other one. So let's minimize passes so we can go on to the next thing. We're going to go into linking, and we're going to leave all this at default. Let's hit OK. And we've got our cuts going around the outside. Now, this isn't too descriptive. If I were running this, I wouldn't know what these different operations were doing until I saw the machine run it. So what we want to do is we want to change the names on these. So our contour 1 is the hole, or you could write bore. The pocket is doing slots. The last contour is doing the profile. And that way it shows up on the setup sheet and in the program with those descriptions. Let's hit save. OK. Let's zoom out a little bit. Let's highlight the stock so we can see the stock. So X should be right to left. And now we're going to simulate what we've done so far. Let's pick on the simulate icon. And you want to make sure that the stock is selected so you can see it. And then we'll press play here, and it should run in order. We've got our 16th end mill roughing the inside. Now we have it coming over and pocketing. Now it's going to go around the outside perimeter. Okay, once you've simulated, now you're going to run a setup sheet. You have to select the destination, and here's your setup sheet. Now look what I forgot to do. I didn't highlight the stock before I made the setup sheet. So let's go back and do that again. Highlight the setup, and it'll display the stock. Whatever you're seeing right here is going to end up in that snapshot. Select folder, and there we go. So now we have an idea of how to set this part up. We're only using one tool, and it's doing 3 routines. Okay, once you've done that and checked for flags for RPMs and feeds and speeds on the setup sheet, you're going to go to post process, and you should have your program number and with the note 12B operational 1. Post processor should be Haas. Select post, select the destination where you know it's going to be, and it should come up in a text editor if you have the box selected to do so. So for your assignment, you need to submit one setup sheet and one program, and in Canvas to get credit for this part. All right, thanks a lot, and I'll catch you on the next one.